Hello, welcome to another Ginger Mathematician video where I'm going to go through the iGCSE 0607 paper 4 from June 2021. So really up to date. Hopefully you'll find this useful. It's a very modern exam that we literally just had 4 or 5 months ago. Okay, let's get started. Okay, so this is the paper we're going to go through. As you can see, this is the 4-1 paper. Now, last time I did the paper 4 series, it did take me quite a while to do all the questions, but I'll try and be a bit quicker today. So let's look at the first few questions and go from there. Question 1. So a stadium sells tickets at 10 different prices for a sporting event, and we've got a table showing what's going on. So we have our ticket prices and then the number of tickets sold. Now, the first thing we need to do is identify the correlation shown by the data. This is a word to be familiar with. So as you notice here on the top row here, the numbers are going upwards, and as these numbers are going upwards, these numbers here are steadily going downwards. So the question is asking, how do we describe this when as the x value increases, the y value decreases, and we call this a negative correlation. So all we need to do for 1 mark is write the word negative. Now if there's a positive correlation, as something rises, then the other thing rises as well. So just know your definitions. Now, question B, find the mean of the 10 ticket prices. Now you could do this manually by adding these up and dividing by 10, but I'm going to use my graphical calculator because it's also going to help me with part C as well. Okay, so make sure you have your graphical display calculator in front of you because this is going to save us a lot of time into the exam. Now I used the TI Inspire, but you may well use the Casio CG50, the TI-84. There's quite a few graphical calculators out there. I personally would recommend this one, but it is really up to you. So to work out the mean of the 10 ticket prices, we're going to start opening a spreadsheet. So we go to the On button, so the main homepage, and what we're going to do is start a new document, add lists and spreadsheet. And I'm actually going to use this part of the question to help me with C later on. So we've got our ticket prices, which we'll label as X, just like in the table here. And I'm just going to type in all the numbers. So 22, 23, 35, 40. Hopefully I can see the screen okay. Hopefully you can at home as well. But yeah, this is easy enough to do. Now, once I've put those numbers in, what I do to actually work out the mean here is go to Menu, Statistics, Stat Calculations, one variable statistics, number of list 1. We're going to select the list, so better to use this button here so I can select the X list. I press OK, and as you can see, lots of data is there for you. Very useful for IB later on if you do the International Baccalaureate. What we need though is just the X bar, which stands for the mean, and that is going to give us 48.9. So all we need to do, we go back to the PowerPoint and I'm just going to write in 48.9 or $48.90. Now I've already done some of the hard work for the second part, which is the equation of the regression line. So as soon as you see this term regression line, we're going to have to put the data into our table. So if I go back, so here's my data. I'm going to add a new column. So I'm going to call this Y, just like in the question. And I'm going to write everything in. So as we go along, 9100, 7000, 7600, 5200, 6000, 4800. Sure, you're having great fun at home writing this into your graphical calculator, and there we are. So we have all the data in here, so we're going to use another button from the menu. So we go to Menu, Statistics, Stat Calculations. This time we're going to just go to Linear Regression, very useful. We click the magic button. Now our X list conveniently is going to be X and Y list is going to be Y. That's why I labelled it up earlier, so you need to make sure you label it. I leave everything else the same, click the OK button, and I get my linear regression line. Now the M represents the gradient, and then the B is the C in Y equals mx plus C. It's an American calculator. And remember, we are going to round to 3 significant figures. So the way we actually write this information in is as follows. We are going to write Y equals minus 120. Remember, 119.7 rounds up to 120. And then for the second part, we're going to write 11,700. Just make sure when you're doing this stage, you always round to 3 significant figures. That's really important. Okay, so make sure you get the fully correct answer there. And at this point, we can actually use this formula to do the next question. So the stadium decides to sell some tickets at a price of $45. So notice we're looking at this row here, and we want to estimate the number of tickets sold. So we're going to substitute X for 45, and then we're going to work out Y by copying out our regression line. The only thing I'm going to do is change the minus 120 to 45. Everything else stays the same. And I'm going to go over to my calculator and type it in. So minus 120 times 45 plus 11,700. And then we get our final answer of 6,300. So again, you can just use your calculator for this step here. We're going to type this back in, the 6,300. And if we look at the mark scheme for this question, you'll notice they give you a range of answers for part 2. So you can see I just used this answer, 6,300. But again, if you use a more specific number, so for example, your gradient minus 119.7, whatever it was, you'll still get an answer that falls within the category. So you get nice 2, 3, 4, 5 marks here. Nice warm-up question on a paper 4. Okay, and on to question 2. So very typical on a paper 4, the transformation topic. So if you're not sure what this topic is called, this is transformations. If you look at my prediction videos, you see this topic comes up very, very often as well. Our first thing we're going to do is translate triangle A with the vector minus 3, minus 5. So reminder what this means. So our top number tells us whether we go left or right. Because it's a negative number, we're going to go 3 left. And our bottom number tells us whether we go up or down. And because it's negative, we're going to go 5 down. So we take our triangle. I'm going to take a point on the triangle. I'm going to take this one here where the right angle is. And I'm going to do exactly that, follow the instructions. So I'm going to go 1, 2, 3, and then 1, 2, 3, 4, 5. So this point of my shape is translated to this coordinate here. Now if we check this, go 1, 2, 3, 4. I'm going to do the same thing. So 1, 2, 3, 4. We go 1 across, and just copying this shape, and then we join up to make our triangle. And it wants us to label this as B. So make sure you do follow the instructions of the question. It did ask us to label this particular image B, so make sure that you do that as well. And now it's asking us for the single transformation that maps triangle B onto triangle A. So what it's asking us is how do we go from this triangle to this triangle here? So how do we do the opposite of what we just did? Well, let's have a think. It's still going to be a translation. So we're just moving the shape, and now we need to state what the vector is. Well, notice if we go back, well, we're essentially going to go 1, 2, 3 to the right, and 1, 2, 3, 4, 5 upwards. So it's exactly the same vector, but this time we make numbers positive. Because instead of going 3 left and 5 down, we want to go 3 right and 5 upwards. Notice it's a 2-mark question, so 2 pieces of information, 1 for translation and 1 for the correct vector. Okay, and on to question C, which is always difficult to do on a computer, but this actually is one of the easier kind of rotations to do. So we want to rotate triangle A through 90 degrees clockwise. So remember, clockwise is in this direction, about 0, 0. So we're going to rotate around this point. Now, as I always say in my videos, when it comes to rotations, use tracing paper. It will make your life easier. However, there is an alternative to doing this that doesn't go into IB Maths, so that'd be good. I'm going to take one of the points on my triangle and I'm going to join it up with the center of rotation. Okay, a little bit, yeah, not quite straight, but it's you can see what's going on. And if we actually look at the gradient of this line, so when I say the gradient, I mean, okay, the change in y over the change in x. Hopefully we can see here that we are actually going downwards, so therefore the gradient 1 divided by 1, but it's going to be a negative. So the gradient of this line is equal to -1. So the way we can actually find the rotation point here is actually find a gradient of a line that's perpendicular to this. So what do I mean by this? Well, I want -1 times something is equal to -1. This is a fact you may have seen in school, that's m1, m2 equals -1. And so I need a number that fits in that gap, and that number is going to be 1, because -1 times 1 is equal to -1. So I need to draw a line that's perpendicular to this and it's got the same length. So this is actually quite straightforward. We can actually draw a line, a diagonal line, up to 4 like so. Notice that these two lines meet at a right angle, which is what has to happen in order for this to be true. Now from there, just like the previous question, we can actually draw our shape in. Now it's turned 90 degrees, so we know now that it's going to look like this using our reference point, and it's going to go across 4, so 1, 2, 3, 4, and then across, and that's going to be our shape C. So let me draw that in and give it a letter. So here we are, C. Again, I really highly recommend you do not use this method. I would use tracing paper every single time, but if you're looking for an alternative, this can also work as well. Okay, and the part D is we need to reflect triangle A in the line y equals x. So just a reminder that the line y equals x is in fact the line I've literally just drawn. So if I do this in a different colour, this blue line is actually the line y equals x, because along this line, let's draw this in, all the x coordinates are equal to the y coordinates. Okay, so now we need to think how this actually reflects across. So we need to think about how we're going to draw this. Well, we take corresponding points. This is the way I tend to do it. So see this green line, it goes all the way actually to the rotation points and the reflection line, and then we just come out the other side. So we want the same length. So 1, 2, 3, 4. So this point will correspond to this point here. And essentially we do the same method with all the different points as well. And if we actually put this all together, we're going to get a shape. This point is going to reflect all the way down to here, 4 minus 5. And then this point here, if we go all the way diagonally across, is going to reflect across to 8 minus 5. So we get this shape here. Again, using that key coordinate to then tell me exactly where the shape needs to go. And so we get our shape here. So we've got 4 minus 4, 4 minus 5, and 8 minus 5 there. So this can be our shape D. So we call that D like so. And that's question D done. And then the last question wants us to do the single transformation that maps triangle C onto triangle D. So the question is, how do we go from this shape here to this shape here? Well, you'll notice it's the same distance away from the x-axis. Notice this is a gap of 4 here, and this is also a gap of 4 here. So our reflection line is actually going to be the x-axis. So if I draw this down a different colour, lots of colours today, this is our reflection line. So now we need to write this in correct mathematical notation. We don't generally write the x-axis when we reflect. We want to write the proper name for it, and that is going to be the line y equals 0, because every coordinate on the x-axis has a y coordinate of 0. So for this part, 2 marks, so 1 mark for reflection, and then 1 mark for the line we're going to reflect in, which is y equals 0. Again, this question would have been so much easier for myself if I had some tracing paper, but if you want to work this out without tracing paper, this is the way to go. Right, check your answers, so you can have a look through exactly what I've done. So this comes directly from the Cambridge exam board, so you can check the calculations I've done. Okay, and on to question 3, which is a little bit of a rarity on paper 4. Generally, this is a paper 6 kind of question with nth terms and sequences, but there's no reason why they can't put it on paper 2 and paper 4 as well. So we need to find the next term in the sequence and the nth term as well. So let's just look at the differences. It's the first thing you should be looking at here. And in this case, the difference is plus 5 each time, which makes our life a lot easier. So the next number will be 33 plus 5, which is 38. So I can pop that in. And the way I generally teach the nth term for linear sequences is I look at my difference. So I have 5, I put an n next to it, and I ask myself, well, what do I do to 5 to get to the first term, 13? And that will just be plus 8. And you can substitute n is 1 in there to check that this works, then n is 2 and so on. So we have our nth term of 5n plus 8. And on to the next question. So again, key thing that we do here, always look at differences. So we're going to look at this difference, which is plus 3. Be careful, this is plus 3, not minus 3. This is plus 5, this is plus 7, and this is plus 9. Okay, so then we look at the second differences. Well, we have 2, 2, 2. Okay, so we have a second difference. So as soon as you see second differences, you need to be thinking quadratic, something with an n squared in. Okay, so as I say quadratic, I mean n squared. I teach this a little bit differently to other teachers, so I'll do it the way I tend to do it. So we take the 2 first of all, and we divide by 2 for quadratics. That gives us 1. And what I'm going to do now is write the n squared numbers. Okay, so I'm going to write the n squared numbers. So if I do that, well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. And what I'm going to do is find the differences between the sequence I've just written and the sequence here. So minus 9 minus 1 is minus 10, minus 6 minus 4 is minus 10, minus 1 minus 9 is minus 10, and you can probably see the pattern here that we're always getting minus 10 when I take this sequence away from my square numbers. And my nth term I can work out from here is just this and this part. Oh. Okay, how do I get out of this? Ah, there we are. So I'm out of it. So I just put these two things together. So I just go n squared minus 10. And don't forget to do the next term. So if this is plus 5 plus 7 plus 9, this is going to be plus 11. So 15 plus 11 is equal to 26. So we're going to pop that number in just there. Perfect. And on to some trickier sequences here. So I'm having a look at this question, and the first thing that comes to mind is, okay, look at those differences, see if we can work out a difference. Well, this one's not so easy to work out, but we can do this on a calculator, or you can just do this by normal subtraction methods. Since I don't want to use my calculator, I'm going to do it using normal subtraction methods. So we get 9, 1, 6, 8, 0, 1. Okay, so this is plus 1089. If we look at this one, I think it's the same, but let's just double check. 3267 minus 2178. Do the same thing, got some borrowing going on. And we get the same number, yes we do. So we get plus 1089. I assume the rest are like this as well. So our nth term, this is a linear sequence, just because it's a weird number. Doesn't mean it's a linear sequence. So next term we'll work out later. The nth term is equal to 1089n. And then we ask ourselves, what do we do to 1089 to get to 1089? The answer is nothing. So that is going to be our nth term, 1089. And so to work out the next term, we're just going to add on another 1089. Let me pop that over here. So we get 5445. Again, I'll just use a calculator in the exam, but I think for me it's almost as quick, just going through this very quickly, and I'm getting the answer as 6,534. Now part D is a little bit different because this sequence is not as straightforward as the ones we've looked at so far. Notice we can't just keep adding, this is the thing, or subtracting, because the sign keeps switching as well, so that's not going to work. So this is actually what we call a geometric series. I've noticed, particularly on later papers, they're putting more of these kind of questions in. And often not a particularly well taught topic either, so make sure you do know how to do this. I'll keep it again as straightforward as possible. Notice here that each time we're just multiplying by -2 each time. So to work out the next term, we're just timesing by -2. Now there is a formula for geometric series. We teach this a lot at IB. Of course, we need to know it for iGCSE as well. So your nth term is equal to the first term times the common ratio, so what you're multiplying by, and then to the power of n minus 1. So our first term of the sequence is equal to 2. And we're going to multiply by the common ratio, which is the -2. And then we're going to write in our n minus 1. So if we write in our answer, we get 2 times -2 n minus 1. Please do remember this formula. If a geometric series does come up, it will be straightforward, something like this. And if we work out the next term where we're timesing by -2, say 32 times -2, well that's equal to -64, which we're going to pop in right there. Okay, so feel free to check your answers, so make sure you've gone through each of the questions I've looked at. Notice this can be written in two different ways. I've written it in the second way. I think that's the most straightforward approach. So I hope you enjoyed the first video of this Paper 4 series. Again, if you do like the content, then please like and subscribe. Please let me know if this is the paper you want me to go through, or there's another paper out there that you think would be more useful to you. Right, see you on the next video. Bye-bye for now.